of sugar packed by automatic loader have an average weight 100 kg with standard deviation 0.25 kg. Assuming normal distribution. Normal distribution means the loader is automatic though it make some mistakes. May averagely it weight the sugar 100 kg, but some sacks will weighted less than 100 or some sack will weight more than 100. The chance is very less though, but as it is a normal distributed, we have to find the sack at weight less than 99.5 kg. As we know in normal distribution we always give inequality, so here the inequality is given for variable 99.5. so we have asked here the chance of sack which are less than 99.5 kg. As we provided here area standard normal as we used in a solution. So now this part is of solution, as this is a normally distribution having average x bar as 100 and sigma, that means standard deviation, as a 0.25. As for normal distribution we convert normal random variable into normal variable z by using relation z is equal to x minus x bar divided by sigma. Now we have to take here x as a normal variable. As we know normal variable in normal distribution is inequality. For here we have given 99.5, so we take x as a 99.5. so for corresponding x we evaluate z by using the formula by putting x as a 99.5 in formula and x bar as a 100 divided by sigma is a 0.25. Now using simplification we get z as minus 2. Yes, minus 2 as a 0.50 minus 0.50 divided by 0.25. We get z is equal to minus 2. The first part is completed. As we get z is equal to minus 2, we can represent this z in this graph of normal distribution. As we know the maximum height which we here evaluated, the point on a curve represent the average of distribution which is here 100. So variable 100 is here, as corresponding z on the axis is always 0. Now you have variable x which is a 99.5, as it is a less than 100, so on a graph it is on left hand side of this 100, as this is we take as a 99.5. so corresponding z by putting perpendicular on axis we have value minus 2. Now we have asked the number of sacks, probability of sacks having weight less than 99.5. that means we have asked the area which is here put by which is shaded, that means on left hand side of 99.5. if we ask more probability of sacks having weight more than 99.5, then we take the area on right hand side of this line. Now we have asked less than 99.5, so we as in figure we put the shaded area. So to find this shaded area, that means area which is less than minus 2 for z is equal to minus 2. So z which is less than minus 2. Now as we know the total area is always bounded by this curve is 1, and the half of area, that means the area for z is equal to 0 on left hand side is always 0.5, on right hand side is also 0.5. so as we have to find the shaded area, we can put this as a 0.5 minus area between z is equal to 0 to minus 2. Okay, that means this area, if total area is subtracted total area subtracted from this area, we get the shaded area. As we are provided standard normal variable area of z 2 is a 0.4772, that means 0 to 2 the area is a 0.4772. as this is a symmetric curve, so on a 0 to 2, that means 2 is maybe appear here, the area is equal area from 0 to minus 2 also, as this is a symmetric curve. So as 0 to minus 2 is the area which we provided, which is a 0.4772. Using this we can find area less than z is equal to -2 by subtracting it from 0.5. So by subtracting it 0.5 from 0.5 minus 0.47772, we evaluated this as a 0.0228. This is the area, that means the number of sacks which is less than 99.5 has a probability 0.00228. The average life of bulb is 120 days with standard deviation 20 days. 1000 bulbs are purchased in a factory. How many bulbs will expire less than 90? As we know, the life of bulb is a normally distributed. So this is a normally distribution. This variable has a normal distributed. So here, as the average of this distribution is x bar is given by 120 days and standard deviation as a 20 days. So we first separated average and standard deviation in this example. Now as we have to use here normal distribution, so we convert the normal variable random variable in a normal variable. So by normal distribution, the formula to convert random variable into normal variable, z is equal to x minus x bar divided by sigma. Okay, now what we have to find here, as we know this is a random variable which are continuous. As in a binomial distribution and Poisson distribution, we define equality or inequality also to evaluate probability, but in a normal distribution we always define inequality. As here given less than 90, that means we have to find number of bulbs having life less than 90 days, mean 89 days, 88 days, 85 days or 0 days, any number which is less than 90. So here take first x as 90, that means random variable we take as a 90, and corresponding we evaluate normal variable z for this x by putting 90 in this formula as x. So 90 minus x bar is a 120 divided by sigma is here 20. By simplifying, 90 minus 120 is a minus 30 divided by 20, 0 get cancelled, we get minus 1.5. So we get corresponding normal variable as a 1.5. The first part of this example is here completed, as we define mean of distribution, standard deviation, as variable x is inequality, as x is equal to we take 90, and the corresponding for normal we take normal variable by using the formula. Okay, now in second part we use the graph of normal distribution, which is a bell shaped curve with a normal variable. As we know, the maximum height between the curve and the axis is a point on a curve represented by mean of distribution. As variable mean of distribution is 120, so 120 is a x on which is represented here, and corresponding z is always 0, that is normal variable is a 0. Now on in this example we take a random variable as 90, so we take 90. As we know 90 is less than 120, so it may occur here or any position on left hand side of this 120. Corresponding this 90, we get the value of normal variable as a minus 1.5. So I put here as a minus 1.5. Now what we have asked here, we have asked how many bulbs will expire less than 90. Less than 90 means we want the area which is a left hand side of this line. Okay, so to find this area we use probability of or area which is having z less than minus 1.5. Now as you understand, the total area under this curve is always 1, and left hand side of this z is equal 0 is a 0.5, as on right hand side it is a 0.5, as we want this shaded area which can represent it as a 0.5 minus area between z is equal to 0 to minus 1.5. Now 0.5 is given. Now as we have to find this area only to evaluate this shaded area, which is equal to 0.5 minus this unshaded area. As in the example, we always given this area. To evaluate to solve such a type of examples, we are given the area here as area of 1.5 is equal to 0.4332. That means area from 0 to 1 point is a 0.4332. As this is a symmetric curve, so on right hand side of 0 up to 1.5, the same area is on left hand side from 0 to 1.5. As it is on left hand side, so the sign of value will be minus. So as on left hand right hand side, if 1.5 is here, then the area from 0 to 1 point and this line will be 0.4332. Similarly, the area from left hand side of 0 up to 1.5, that means this area is we have provided that is 0.4332. Now to evaluate the shaded area, we minus this unshaded area from 0.5, so we get the value as 0.0668. This is the area which we want. As in the example, we are given that total number of bulbs are purchased 1000. That means the distribution of this area is of 1000 bulbs, out of which we define this much area. So the number of bulbs represented by this much area, which is 0.0668, we have to multiply this area by 1000. So we get the number of bulb having life less than 90 days is equal to this area 0.0668 multiplied by 1000. So multiplying by 1000, we get the value at 66.8. But as we know, the value of bulb is should be integer, so there is no half, like half or 1/4, 3/4 area, 3/4 bulb. So we take it as a 67 or 66. That means out of 1000, 67 bulbs will have life less than 90 days.